So in this video tutorial, I'd like to show you how to calculate the standard scores using Jamovi. So here we have this Excel file, the large calcium from the previous exercise. So let's just open this in Jamovi first. So it's loading in the background. And so you can actually open any Excel file directly from Jamovi by clicking this three lines on the left. Click open and browse. Then you just need to locate the Excel file to open. Then it opens up right away, even though you need to do something before you do any analysis on the data, because so automatically, as you can see, the column headings of the Excel file is actually used as the header for Jamovi, but when it is imported into Jamovi, it actually automatically detects what kind of variable each variable is. So what level of a measurement each variable is, but it is not always accurate. So let's just so this way. So if you look at age is not nominal. See, these three circles represents a nominal variable, but age is continuous variable. So you want to double click on the header and assign the proper level of measurement, which is continuous. Right, so this is what you should have done for the previous formative exercise. Everything else looks all right. Age group can be ordinal, but it doesn't really matter at this moment. So let's take a look at the calcium data. So descriptive. In fact, let's just look at all the, by the way, to be able to calculate the standardized score, the z-scores, and the variable should be at least interval level of measurement, right? Because you need to be able to calculate the mean and the standard deviation to convert any raw score to the z-score, right? So let's just get the mean and plots. Let's see what happens. Okay, so this is a histogram of age. Obviously, this is a positively skewed. And that is actually shown in the box plot too. You have longer upper whisker with 3 outliers up here. For calcium, it looks all right, more or less symmetrical around the center, and except for one outlier down below. And it's the same thing with inorganic phosphorus, more or less symmetrical around the center, except for this single outlier. So let's calculate a standardized score for age first. So to calculate the z-score, you need to know the mean and the standard deviation of the variable, right? So what you need to do then, you go back to data, and you want to have computed variable, which will be which you call like ZH. ZH. And if you click on this formula editor, then you will see the variable. So we're going to convert the age into the standard score. So you double click to move age variable, and you subtract the mean of the age, right? So you can just type in, the mean is here, right? 72.3, and divide this by the standard deviation, which is 4.86. Okay, so if you just hit enter, then here we have the ZH, right? So these are the Z-score, the corresponding Z-score of each age data. So what that means is that for this first data, right? So the age is 78, right? So that age is actually 1.173 standard deviation above the mean. That's what it means. So the second one, 72, that score is basically 0.062 standard deviation below the mean, because now you have the negative sign in front. And if you have the same score, then they have the same Z-scores, right? So 73 is actually 0.144 standard deviation above the mean. So that's what that means. So let's just, I'll just remove everything. Wait. There we go. So let's just go back to analysis again. Right, so everything's resetted. Now let's just move age and ZH to the variables. There's no missing variables, I mean. Again, density, box plot. So this is the raw distribution of the age variable, and again, this is box plot. And as you can see, so I don't know if it is really clear to you, but the shape of the distribution, even after the transformation, Z transformation, looks exactly the same, right? Except the unit on the x-axis now changed. So 0 is where the mean is, right? Which is about 72.3. So that's where the mean is. And the spread is exactly the same as the raw distribution too. And your box plot after the transformation will be also looking exactly the same as the raw data. And the location of the mean is always 0, right? Because the Z-scores are centered around the 0. So, if you see the Z-score of 0, then that is where the mean is, right? Whatever the mean is. And see, after the conversion, the Z-score, the Z-score for the mean is this value, and this is basically the rounding error, but it is close enough to 0, and the standard deviation is close to 1, right? So that is how you calculate the Z-score of a data set using Jamovi.